Now we have the same project in two separate repos, orange and purple. We are working on purple, so it would be useful if purple could remember the address of orange, because we decided that orange is an important copy and we want to stay synchronized with it. Indeed, when we issued the git clone command, Git added a few lines to the configuration of our repository. It's here in the config file. We never looked at this configuration file before, but now that we cloned the repo, we can find some useful information here. Each Git repository, such as this one, can remember information about other copies of the same repository. Each other copy is called a remote. You can define as many remotes as you want, but when you clone the project, Git immediately defines a default remote and calls it with a conventional name, origin. Here is the configuration of origin, and it points to the URL that we cloned the project from. The rest of the configuration is more complicated. We don't need to look at the details here. Just know that the default configuration says that we have one main branch that maps over the main branch of the remote. You can tweak this configuration to change the policies that you use to synchronize with the remotes, but this configuration here is the default. So now Git remembers which other repo or repos we want to synchronize with. But to synchronize, Git also needs to know the current state of origin, which branches are there on the remote, which commits those branches are currently pointing at, and so on. And in fact, Git does store that information. If we ask it for branches, it shows the local branches. We only have main now. But if you list the branches with the --all switch, then you see all the references, including the ones on the remote branches and the current position of head. Git tracks remote branches exactly like it tracks local branches by writing those branches as references in the refs folder. If you look inside that folder, you will see an origin folder in here that contains the references to branches, tags, and the current head pointer of origin. Git will automatically update this information when we connect to a remote. There is one wrinkle here. If you look inside this folder, you might find that some of the branches are missing. In this case, I can only see the remote's head here, not the branches. That's because of a low-level optimization in Git. To avoid maintaining one small file for each branch, Git sometimes compacts some of them into a single file called packed refs, here. There is no simple command to unpack these files, so you will have to take my word for it that the branches that are not in the refs directory must be in this file. This can happen for both local and remote branches, but in both cases, whether the branches are still individual files or packaged together in packed refs, they are still conceptually the same thing. All branches, local or remote, are still references to a commit, and Git tracks all of them. Since we cannot peek inside the files for some of these branches because they've been packed, let's use this plumbing command git show ref to see which commit they're pointing at. Git show ref main lists all of the branches that have main in their names, which means the local main branch and the remote main branch, and as you can see, they're pointing to the same commit, while the ideas branch is still pointing to an older commit. So, bottom line, you know that the local branch in Git is just a reference to a commit. Well, a remote branch is exactly the same thing. Whenever you synchronize with a remote, Git updates remote branches. Let's see how that synchronization happens in practice.